Yeah, hi all. So today's topic is on bit manipulation. Okay. And today's approach will be a bit different because I just realized that before learning anything, we have to understand why we are learning, right? So going forward, each topic will first try to understand why we are learning and then what we are doing. Okay. So today's topic, as I said, it's a bit manipulation. So first, let's understand why we have to learn bit manipulation. Okay. And before jumping to bit manipulation also, if you recall the in first class, I had said the computers do not understand our high level language or any English language. They just understand what? The binary code that are 0 and 1. Okay, so bit manipulation is nothing but changing this 0 and 1 values. Okay, 0 to 1, 1 to 0, depending on the conditions. Okay, then why we have to learn it? Let's see. Okay, so the first 2 points says that it is efficient memory usage as well as performance optimization. Okay, but how to understand it, like efficient memory usage and performance optimization? So in simple terms, let's say number 1 and number 2 is there. If you are trying to add it, what usually happens is that entire bytes, whatever is there, like each number, whatever you consider, can be represented in the byte, let's say 0, 1, 0, 0, 1, 0, 1, something like this. And this is also 0, 0, 1, 0, 0, 1, something like this. And when you are doing addition, you are adding this entire byte to this entire byte. And finally, you will get an output, which is in the byte format. And then you are converting that byte to a number, let's say number 3. Clear? But when you understand the bit manipulation, when you have the understanding of the bits, instead of adding this entire bit, what you will get the inside. What are the inner values only that, let's say we have to add only these 2 numbers and we'll be getting the number 3. So these are some easy tricks, you will get it. And when you understand these concepts, that time efficient memory usage can be done as well as the performance optimization can be done. And to understand this, we'll be having simple functions also where we'll get an understanding how this is possible. Yeah. After that, what's the next thing is it helps in low level programming. This will directly interact with the machines or let's say the hard disk and all, and which gives you like greater control over the program. Like let's say you can also build your own operating system when you have the knowledge of bit manipulation and other. Clear? Then the next topic is cryptography and data security. It means, let's say you have any data or let's say you have any video, to encode it, like anything to encode it to secure the data. That time the concept of bit manipulation is there. Then bit level representation, then solving the algorithm problems as well as the interview preparations. Okay. So these are all the concepts why we are learning the bit manipulation. Clear? So once we have understood this, now how to approach it? So the main fundamentals for this bit manipulation is the bit operators. What are the fundamentals? These are the fundamentals. Let me minimize this. Okay. So once you master these bit operators, that is AND, OR, XOR, complement, and these things, once you gain the master, then you can do any types of function. Okay, but before this, there is again a prerequisite. You have to know how to convert binary to a decimal, that is, let's say a number, and from a decimal to a binary. Okay, so let's first focus on this. Let's learn this, and then we'll jump to the operators part. Clear? So let me clear this screen, and let me put it here. Okay. Now, there is an easy trick as well as a general approach how to convert the numbers. First, let's see the general approach, how it's done. Let's take any number. For example, let's take a number as 4. Okay. How will you convert this 4 to a binary code? You have to simply divide this by 2. So 2, let's say here it is 4. 2 2s are 4. You will get the remainder of 0. Okay. Then let's take one more. Again, 2 1s are 2, you will get a remainder of 0 and you have a 1 here. So finally you have to sum it up. So what it will become is 1 0 0. Clear? So the binary code for 4 is 1 0 0. Let's do one more number. For example, let's say 7. Okay, for 7 you will first write 7. Then you will do divided by 2. 2 how much are 7? 2, let's say 3s are 6. 6, you will get the remainder as 1. You have a 3 here. Then 2 1s are 2. You will get the remainder as 1. 1 is here and 1 is there. So finally the output is 1 1 1. Clear? So 7 can be represented in the form of 111. Clear? Now, in case if you want to convert this binary code to a number, then how you can do it? So let's take this 4 itself. So for example, here we have 100. Now, how can we convert it? So we'll always start from the right side, and we'll say the rightmost position is 2 raised to 0. Then here it is 2 raised to 1, 2 raised to 2. And if there is any number, we'll just go on increasing the power exponential. Okay. Presently, we have just 3 numbers. Okay. Then what we are going to do is we are going to multiply this with the value of 2 raised to 0. So this is nothing but 0 into 2, 0. Then plus what we are going to do, we are going to take this value. So what is the value? 0 into what is the exponential, like the original 2 raised to 1, plus the value is what? 1 into 2 raised to 2. Okay, so here is as 0 is present, so obviously the value is 0. Here also as 0 is present, so the value is 0. Yeah, and finally the value of this is what? 2 2s are 4, and here 4 into 1 is nothing but 4. So finally, if you see, we got an output as 4. Yeah. Similarly, let's do it for 111. So here I have 1 1 1. So this is nothing but 1 into 2 raised to 0 is what? 2 raised to 0 is nothing but 1, right? So this is also 1 into 1. So we finally get the output as 1. Then here what it is? 1 into 2 raised to 1. So it is 2. And here we'll get the output as 2. And here what it is, the output? It is 1 into 2 raised to 2. 2 2s are 4. 4 into 1 is nothing but 4. So we get 4. And if we try to add it, 4, 5, 6 plus 1, 7. So here if you see, the final output is also 7. Clear? Okay, so once we have understood this, then should we always do it in this way? No. There's a bit easy trick, and how I usually do it is, you have to simply remember the power of 2. For example, as we had discussed the places, right? So it will start from here. So 2 raised to 0 is what? The answer of this is, first let me write the values. That is 2 1, then it is 2 2, then it is 2 3, then it is 2 4, and so on going forward. Let's say 2n. Okay. Once you have done this, you have to simply note down the values. Like it's not necessary, it will be in your mind itself, like after a few problems. So 2 0 is nothing but 2 raised to 0 is nothing but 1. 2 1 is nothing. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8, and this is 16. Clear? So once we understand this, now let's say we want to convert number. We want to convert number to binary code. So as this is our target, so let's see. First, what is the number? First one is 1. So if you see here, only 1 is here, present here. So what we can say, we can just take the 3 decimals at the beginning, and here we can, if we put 1, so we'll get the binary code as 1. So 0 0 0 1. Clear? So let's say 2. How can we 2 represent it? If you see, the value of 2 is here. So I can simply put 1 for this. So we'll get the value of 2. So I can write it as 0 0 1 0. Clear? Then value of 3. How can I get the value of 3? If you see, there are no odd numbers and there are only even numbers. So I have to find some combination. So can I do 2 plus 1 will give me 3, right? So here I have to write 1 and 1. So this will be nothing but 0 0 1 1. Clear? And what about 4? 4 is nothing but 4 we can directly get here. That is in this format. So I can write 0 1 0 0. Then similarly for 5. So for 5 it is 4 and 1. Adding of 4 and 1 will give us 5. So 4 is in 3rd position and 1 is in 1 position. Okay. So 0 1 0 1. Then we have 6. Let's say for 6 what it will come? 4 plus 2 will give us 6. So it will be like 0 1 1 0. Then let's go with 7. Then 4 5 6 7. Right. So that will be nothing but 0 1 1 1. Clear? So at least it's important for us to remember the numbers up to 7. Okay. Because after this, again, the concept repeats. Now, once they all are filled, then again the next number will come from 8. Okay, so 8, how it will be? 8 is nothing but 8 can be represented as 8 directly value is here 1 0 0 0. And then if you want 9, then 8 is here 0 0 1. 1 will get here. Then if you want 10, then 8 you have to take and 2. So that is nothing but it will get 10 value will be written as that is in 1 0 and 2 value is 1 0. So 8 and 2 it will become 10. Clear? Okay. So I hope you have understood how to convert from number to binary code. Okay. And once you have understood this, then it's not hard for you to reverse the number, like binary code to number. So for that also, let's take a quick examples. Let's take this number itself, 0 0 0. We know that in first position, it is always 1. The values are 1. So here we know the answer of this will be 1 itself. Here we always know in the second position, the value is 2. So, okay. We know that 1 is here and 2. So 1 plus 2, it will become like 3. Similarly, here we know that the 2 raised to 2, right? So 2 2s are 4. So here the value is 4. Clear? Similarly, everything is. Now, if you are confused, like I'm just copying from the number here, let's take any number, random number, let's say 1 0 0 1, and take like 1 1 1 0. Then let's take 1 0 1 0, and let's take 1 0 0 1 0 0. Okay, these are some random numbers which I don't know the values. I have randomly written. So let's say the value of this is what? 1. Okay. Plus what is the value of this? This would be 8. 8 plus 1. Okay, this is 9. Then what is this? This is 8. 8. Then afterwards 8 plus 4 will give us 12. 12 plus 2 will give us 14. Okay. And let's say what will be this? This is nothing but 8. 8 plus 2 will give us 10. Okay. What about this? This, if you know, the value is 16. Okay. This value is 16. 16 plus what is the value of this? This value is 2. 16 plus 2 is 8. Clear? So let's check it. So for confirmation, I have a website opened here. So, okay, let me clear it. So let's say the enter 18. So 1 0 0 1 0. And if we go back here and if we pull back our image, 1 0 0 1 0. Okay. And if you see here also, it is 1 0 0 1 0. Okay. Then let's do for 10 and convert it. So it is saying 1 0 1 0. Okay. If you see, it is 1 0 1 0. Okay. I know it's hard to see, but let's quickly do it. And what about 14? Let's convert it. And if you see, it should be 1 1 0. And here, if you see, it's 1 1 0. And even here, I'm getting it as 1 1 0. If you see, for 14, I have written 1 1 0. And for 8, it should be like 1 0 0 1. Let's say it is same for 8. If I convert it, okay, we got 1 0 0 0. Let's see for what we had got. Oh, it's 9. Our final value is 9. So obviously, let me enter again 9. And let's convert it. And if you see, the binary code is 1001, and even we got 100. Clear? So what we understand by this, to convert any binary code to a number or number to binary code, it's important that if you just recall these numbers, okay, the 2 raised to what, and if it is, and it's better if you remember whatever are the values here. So 16 into 2 will be nothing but it will be 32. And 32 into 2 will be nothing but 64. 64 into 2 will be nothing but 128. Clear? So in this way, if you remember, even these are like, it's easy. You have to keep on multiplying with 2. So into 2 will give us 8. Into 2 will give us 16. Into 2 will give us 32. Into 2 will give us 64. 64 into 2 will give us 128. 128 into 2 will give us like 56. So 256. Okay, into 2, this will give us something like 512. Yeah, so multiplying by 2 is also easy, and converting these numbers is very simple. Yeah. So I assume you have understood how to convert binary code to a number, and how to convert number to a binary code. Yeah. So once we have done this, let's go to the fundamentals. So the fundamentals, if you see here, Those are the bit operators and or sort. So till here, there is at least no problem. You have been studying this all. Okay, let me quickly do the table. I know it's basic simple, but it's important to recall because our all foundation is dependent on this. So let's say the values are 0, 0, and 0, 1, 1, 0, and 1, 1. So these are the values. Let's say this is A and B. Okay, our final this outputs, and based on this, we have to find out what is the output of AND or AND SOR. Okay, so to understand it, let me do first A and B. So A and B will always give like a 2. So this you can consider 0 as false. 0, 0 will be nothing but 0. And for true, we know, for and we know the condition like it should be always true. So here, when both are true itself, it is going to give us one rest, or it will give us false itself, like 0, 0, 0. Okay. Yeah. Similarly, the opposite of this is what? Or. So if I do A or B, then this should give me the output as for 0, 0, it should give me 0. For 0, 1, it should give me 1. 1, 0, it should give me 1. And 1, 1 should give me 1. Clear? Okay. Then our next operator is XOR. So let me write A XOR B. So for this, the condition would be like whenever they are same, then it's considered as 0. For example, here 0, 0 would be 0. Similarly, 1, 1 would be 0. Apart from that, if there are any values changing, like A is 0 and B is 1, then it will be 1. And if A is 1 and B is 0, then also it will be 1. Clear? So this was something new, I guess. We had not yet discussed, but this is the similar to your AND operator and OR operator, which we had discussed previously, logical operator. Okay, there we had true and false. Here we have something called as 0 and 1. Okay, you can consider 0 as false and 1 as true. Clear? Okay, so once we have understood this, now let's move to the next part, that is complement. Let's do one thing. Before moving to complement, let's first code the above part, that is AND or AND OR, because we'll complete it once, and then we'll move to complement, because I don't want you to complement the other thing should be like vanishing from your brain. Because once you learn the complement, your brain is going to be somewhat like this. Okay, so yeah, let's move to the code. So let me open the editor and let me bring back my table. So yeah, I have a table here. So let's quickly do it for just 1 and 0. So for 1 and 0, I'll be doing south. And let me say 1 and 0. Yeah, so what we expect if it is and 1 and 0, it should give us 0. So let's see if it gives us 0. Clear? It gave us 0. And in case if we put or, what will happen? 1 or 0, it should give us 1. And let's see if it is giving us 1. Great, it gave us 1. And similarly, if we give this symbol, XOR, the symbol is this. And if I try it, clear. So it is still giving 1. Okay, you can try this all. It still gives 1. But what if I give now 5 and 4 or 5 and 6? For example, let's try this. 5 and let's first try it 5 and 6. So what do you think the output will be? Let's first run it. So we got 4. Oh, so let's try to do it. For example, let me close this part first. Okay, what we got the output as 4. Okay, for 5 and 6, the output was 4. Okay, for 5 and 6, first let's put it in the binary code. For 5, how we can write? We can write 4 plus 1. So 4 is in which position? It will be in third position, right? So third position, second position will be 0 and 1 we want. So that is 1, 0, 1. And how can we write 6? We can write it like 4 plus 2. So 4 is in which position? Third position. And 2 is in which position? Second position. And 1 position, what we want? 0. Clear? So we have these two binary codes. Now what we have to do? We have to do AND. So let me write it in this way: 1, 0, 1 and 1, 1, 0. So AND I am doing. So 1010, what it will give me? That is nothing but 10. This will give me 0. Okay. Even 10, what this should give me? This is also giving me 0. Then 11 will give me what? 1. And if we convert this, what is 100? It is nothing but 4. Yeah, because in this position, what it is? 1, in this position 2, and in this position we have 4. Therefore, we get to know that if we do 5 and 6, we get 4. What will happen if we do 5 or 6? So again, we'll take the same binary code. So we have 101 and 110. And for even if it is 10, we are getting 1 itself. If it is 10, we are still getting 1. And for this also, we are getting 1. So what is the value of this? This is like 4, 5, 6, 7. So we should get 7. Let's check if we are getting 7. Let me clear the screen. And let's put here OR. And let's run it. Cool. So if you see, we got 7 as the output. Okay, now let's try for XOR. So before XOR, let me pull back the image and let's do it for XOR. So 5 XOR 6. So 5 value is what? 5 value is again 101. And 6 value is what? 110. And if we do XOR, we know that if both are different, then only it will be 1. Okay, this is also 1. And if they are same, we are getting it as 0. So what is the value of this? The value of this is 3, because this is in 2's position, and 1, 2 plus 1 will be 3. So let's see if the answer is correct. Let me clear the screen. And let's put this like this and run it. Cool. So you see, we got 3. Okay. So I hope there is no doubt in this and OR and XOR. They are pretty simple enough. You have to just convert the binary code, and whatever is the output, you have to then convert it to number, and you will get the XOR. Clear? Okay. So the next topic is complement. Listen it carefully. If you miss here and there, it will again be a bit of confusing. Okay. So let's start. So complement, the symbol is like this, and it's a unary operator. That means it will act on either like 0 or 1 at a time. So let's say if it was a 0, this will convert as 1. And if it is a 1, this will convert as 0. Clear? Okay. Any doubts still here? No, right? Cool. Simple enough. But now let's try to implement it. So if I do a complement of this, so I'll use this symbol, and if I do 1, and if I run it, so if you see, the output is what? -2. Okay. Let's put for 5 and run it. Okay. The value is what? -6. It's different, right? For 1, what we are learning, it should be 0. Okay. But try to understand here, the one which we are writing is a number. Okay. This one, what we wrote initially, that was a number. And this is a binary code, binary 1 and binary 0. Okay. For example, 1 is represented how? It is represented as 1, and before 1 there will be lot of zeros. Okay. It depends on how many bits you are operating. Like let's say if there was only 4 bits, then you are operating like there are only just 4 symbols. If it is a 8-bit, then it will be 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros before 1. Okay. This is known as binary code of 1. Okay, when you put this symbol, that is nothing but then this entire operator's value will be changed. So it will be 1, 1, 1, 1, 1, 1, 1, 0. Clear? Okay, cool. So understood still here? Okay, the first point was whenever we do complement of 1 in our code, this is for we are applying it for number. Okay, and if we are applying it for binary code, then only it will give us 0. This was the first point. Okay, that got clear. Second point, if we try to see now, is if we just go for this number at least, like let's say if this number were also not there and we are having just this 4 numbers, and if we go to number like this, like this was 1, 2, this was 4 and 16. And if we see, it should be at least, if this value is 16, then we know by adding it will be at least greater than 16. Okay, but what we got the value? We got the value as -2. Now, how is that possible? Because here there is a concept now called as LSB and MSB. So this point is known as LSB, the least significant bit, and this point is known as MSB, the most significant bit. Okay, the MSB is the one which defines if a number is positive or a negative. Yeah, if in a MSB's place, if there is a 0, as it was in the starting point, then it is considered as a positive number. And in case if there is a 1 in this, then it is considered as a negative number. Clear? Okay. So what is our second learning? Second learning is that there is something called as concept as LSB and MSB. And MSB is the one which identifies a positive number or a negative number. Depending if the MSB has the value as 0, then it is a positive number. If it has a value of 1, that's a negative. Clear? So this was our second understanding. Clear? Now what we understood is okay, the symbol for this minus is with the help, like due to MSB, the minus symbol was there. But now the question is, how did this 2 come? Clear? So to answer this question, let's again take a number, the same number. So now I'll reduce it to just 4 bits. So I have 0, 0, 0, 1. Okay, this is what? This is binary code representation for 1 when the memory bit size is of 4. Okay, and if I do it the conversion, that is the ones complement, then this would be 1, 1, 1, 0. Clear? This is known as ones complement. Great. So, and why it is known as ones complement? Because if you just try to add it, you will get all 1, 1 value. So it is 1, 1, and 1, right? So if you will get all the binary code representation of 1, 1, 1, 1. So for that reason, it is known as ones complement. Good. So we have not yet arrived to our answer. So let's pause it here. Let's pause the here and let's take a new problem now. And here, let's try to write this 2. Okay, so how can we write a 2 in these 4-bit memory space? So that will be 0, 0, 1, 0. And let's do the complement of this. So the complement of this will be 1, 1, 0, 1. So this is again one's complement. So here, if we try, we'll get all 1, 1. Clear? Let me just highlight few parts. Just a second. So let me highlight this one. Okay. Now, once we get this one's complement, what we are doing is we are just adding +1 to this, and then what will happen? 1, 1, it will carry forward, and here we'll get 0. The next value will be 1, 1, 1. Okay, this is how what I did. This was 2 initially. I did its ones complement. Then I got a binary code of 1, 1, 0, 1. Then I added just 1 to it. It carry forwarded, and finally from this I got an value which is in the form of 1, 1, 0. Okay, now if you try to compare this and this, okay, aren't they both same? Okay, so this proves that whenever you do any complement of a number, let's say, let me erase few parts. Okay, let me repeat. So whenever you do a complement of any number, let's say 5. Okay, this is nothing but the minus symbol, whatever is our 5 value, 5 plus 1. Yeah? So this would be -6. Okay, let's take any number. Let's say 42. The complement of 42 will be what? Minus symbol, the 42 value plus 1. And this would be -42. Let's check it once. So let's put the complement here as first. Let's check it for 5 itself and run it. So, okay, it's -6. And let's change it to 42 and check it. Okay, I forgot to plus here. So this is nothing but a silly mistake here. 42 plus 1 would be 43. And if you see, the value is 43. Clear? Okay, so what was the first step? First step, whenever we use a complement, we are changing the binary codes 1 and 0 and not the 1 and 0 of our number. So that was one confusion which was avoided. The second thing was what? the MSB, that is the most significant bit present on the right side, will determine if a number is positive or a negative. Okay. Then here, if we see, there are 1. So therefore, we are getting every time the negative as the number. Okay. Then after that, what we saw is we saw a proof which says that whenever you do minus like this, whenever you do complement, the value will be whatever is the present value plus 1, the minus symbol. Clear? Okay. If you have still not got it, there's again a visual representation. Okay, let's consider here, focus this part. So this is in which position? This is in 1's position. This is in which position? 2, 4, and 8, right? Our MSB is what? Our MSB is in the rightmost value, and it is 1. Therefore, the symbol is what? Minus. And the value is what? 8. Okay. Then after that, which we have 1. So let me do plus 4. Then after that, what is the value? 1. This is in present in 2. So that is plus 2. And if we try to add on, so 4 plus 2 is 6. And if we do it with minus 8, it will be minus 2. Clear? So this is how the minus ones, the ones complement is minus 2. Clear? Okay. So I hope you have understood the concept. If not, a last thing which I can help in is trying to write down any negative numbers. Okay, let's say we have given that our memory size is just of 4 bits. Okay, and we have to write a value as -4. How can we write it? First, let's say we have the values like this. And as it is a minus value, then what we know, the 1 will be here. Okay, so if 1 is here, then we got to know if the value is minus. Then the next part, what is the value of this? The value of this is 8. Here it is 4, 2, 1. So here it is 8. Now, what I want, my target is to get 4. So I have to simply subtract 4. So here it will be again 1 and 0, 0. So this will be 4 here. So the value is -4. Okay, so this is what now? This is the value for -4. Okay, when our memory size is 4-bit only. Okay, in case if our memory size was 16-bit, then what would have happened? We could have still more zeros here, and as MSB is 0, therefore our value will be plus positive, and thus then that time what would be the value of this? This would be 8 plus 4. It would be 12. Okay, so I hope you have understood the concept. If not, just rewind it back, because this, as you have knowledge of this now, just rewind it back and watch it again, the complement part itself, and it will be understood. Yeah. Okay, great. So let's move to the next topic. The next topic will be left shift and the right shift. These are pretty simple enough. So let's assume a binary code as 1 0 1 0, something like this, and we have also 0 0 here like this. So when you do a left shift, so left shift in sense it will go this side, and we are given that 1 2 3 4 5 6. So we have only 6 bits. Let's assume the memory space is only of 6 bits. So when everything moves to the left side, so this will be popped out. Okay, as this will be outside, it will be popped out. We are left with our memory size only this much. This will come in this zeros position. This will come in 1 0 1 0. And for a new blank space, we'll get 1 0 here. Right? It's not like necessary that we always shift it by 1. We can also shift it like multiple 2's positions. So even this same thing can be done like this itself. So for example, what is this? This is actually, first of all, this is from 1 2 4 8 8 plus 2. So this is the value of 10. And if I write it in this format, 10 left shift of 2. So this would be, let me write it here again, 0 0 1 0 1 0. So these both will be out of our scope, and we are left with 1 will come here. Okay, 0 will come here. Then 1 is again pulled this side. And we have a 0 here. Again, one there will be a space 0 here because 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There should be one more memory space. Okay, because 2 are pulled out here. So 2 will be added at here. And what if you see the value of this? It will be what? The value of this will be like, let's say here it is 1, then here it will be 2, then here it will be 4, 8, 16, and this would be 32. So 32 plus 8 will give us an answer of 40. Clear? So did you get it? So what I did for this 10 left shift of 1 gave us an output of, what is the output of this? This would be like 1, 2, 4, 8, and 16. So 16 plus 4, this will give us the answer as 20. So for this, the answer is 20. Whereas for this, the answer is 40. Okay, first let's check it. So let me go back to the code. Yeah. So let's do south, and we had number 10, right? And we did left shift, 2, right? So if I run it, the answer would be 40. Yeah, let me bring the image back. So if you see 10 left shift, 2 is where it is 40. Okay, why is this one missing? Okay, the 40 is here that we want to know. And if I just do left shift 1, and we know the answer should be 20. Correct? Clear? So I hope there is no doubt here. And is there any logic here, like anything like that's happening? Yes, there's a bit of logic. To understand that, what I'll do, I'll take an example of 2. And here I'll say, like first, let's do it with 1. So for 1, if you see, it is getting double. So if you do, first of all, with just 1, if you do left shift with 1, no matter it is any number, like let's say 8, it will always double the value. Okay, 16, that's the first point. 56 would be 112. Okay, that's correct. So first point is that. But what if I kept on increasing this number, like 2? Let's reduce this to 2, so we can do calculation. So this would be 8. Okay. What if I increase it to 3? Then this should be 16. Correct. And if we increase to 4, and then it should be 32. So how I came up with the logic? So x into x multiplied by whatever is 2 raised to n. Okay, for example, now we said 4 is considered as n and x is considered as 2. So x is here, I'll write 2. So this is multiplied by 2 raised to 4. So this will give us what? 16. And if I do into 2, this should give us 32. And if you see the output here, it is 32. Yeah. Let's do it for another number. For example, let's take, what shall I take? 10. And here I'll take same. So into 2 raised to 4. So this will be like 16. 16 into 10 will be 160. So let's see if we get 160 for this. And if I run it, clear. If you see, we are getting 160. Okay. So I hope there's no doubt in this left shift. We are just shifting the values in the leftmost side. Now, when we come to right shift, it's again shifting the values in right side. So let's take the example of that. So let's say we have a number 1, 1, 1, 1. So what is the value of this? This is 1, 2, 2, 4, 8. So it would be 8, 10. 10 plus 4 is 14 plus 15. So value is 50. And if I do left shift of 1, then this would be what? 0, 1, 1, 1. And what is the value of this? The value of this would be 4, 5, 6, 7. Clear? If I do the left shift of this, then the value of this will be 3. Sorry, right shift. Shift. Okay, did I say left shift? It is right shift. This is 0. And the value of this is 3. Okay, so even here there is a formula that is x divided by what it was 2 raised to whatever our n is there. That is the shift that we are doing. This is the formula for right shift. Okay, if you are not there, you can also check it in this way. And if you want to remember a shortcut, you can also keep this formula in mind. Clear? So let's try it. So for what is the value of this? For 15, we should get the value as 7. So let's see if we get that. So I'll write 15. I'll do right shift. And how much I have to do is just by 1. And if I run it, 7. If you see, we got 7. And if I do it for 7, it should give us 3. So let's see if it gives us 3. Yes. And if we do it for 3, obviously it should give us 1. So let's see if it gives us 1. 1. Clear? Okay, cool. So yeah, now we are done with the fundamentals. So let's try to put our knowledge into creating some functions. So this is done. So based on this, the functions are there. We'll try to do few of them. If you rest, you can do it as a homework. Okay, so let's first go with an odd and even. So how can we find a number is odd or even? So first, let's try to write a logic for that. Consider any number. So if you have seen, like, for example, the value here was 1, 2, 4, 8, and 16. So to become a number, if it wants to be a even, we know that here at the LSB, this significant bit, it should be always 0. Why? In case if it is 1, then what we are doing is we are adding 1 to it, and then only it will become odd. Why only this adding this will become odd? Because rest, apart from this, here everywhere the number is multiplication of even 2, 4, 8, 16, 32, and so on. So only we have to check for our least significant bit that if this number is 0 or 1. If it is 0, this is equal to even, and if it is 1, this is equal to odd. Clear? So how will we identify that? Let's have a few conditions. Let's have a number as 101, 110, and let's say 1011, something like this. A random numbers I have picked. I do not know the value of those. So for this, what is our first condition is that we have to find out the position. What is the value stored here? What is in the LSB? What is stored in the LSB? Okay, so how can we do that? Any idea? So for that, you have to take the help of your operators that you have learned. Okay, our entire bit manipulation is based on this operators itself. Okay, so we have to put a number here such a way that here we get it 1, and remaining apart from this, here everywhere we can get, let's say 0, 0. Clear? So how can we do that? So we know that if I put 1, what will happen? And if I use an AND operator, what will happen? Let's see. So 1, 1 will give us what? 1. Okay. And is there any values to be given here? Not required. We'll not just consider this. So if I just put like this, then what is happening is, and it will give us 1. Okay, let's see if it works for this also. So if I put 1 here, so 1, 0, if it is an AND, it's giving me 0. Okay, this condition works here. And if I put AND 1 here, so 1, 1, it is giving me 1. Okay, so this, yeah, that's it. So what we have to do, this is what we'll get it by our number. This is our number. We have to use our AND operator with 1. Okay, and then we have to put a condition that if it is equal to 0 or 1. Yeah. So let's code it. Let's come back to our coding. Okay, let me pull back the image. So let me create a function for that. Public static method. Okay. I don't want to return anything. I'll just display it there itself. And here I'm saying odd and even. Okay, and do I need any arguments? Yes, I want a number, int num, correct? And here I am directly displaying. Okay, so you can put this return the values. I am directly displaying. So first of all, what I want num. Okay, then which operator I want? And. Okay, and then what I want is I'm comparing it with one. Okay, then if it is equal to zero, then only it is even. Okay, or else odd. Okay, so let me write the condition. So if zero, it will return what it will return? True. Okay, which is equal to even. Okay, so now the image is not required, and let me run. I have to pass the number. So let me delete this, and let me create a call this function name that is odd and even. Okay, let's pass zero itself and see what's happening. True. So okay, that's an even number. Let me put anything like 6. That's also even number. That's good. 61. False. Okay. 62. 612. 2. Okay. 35. False. Okay. Correct. So if you see, it's completely working. Okay. So what was our logic? I'll repeat. Our logic was take any number, let's say 101, any number, and we are interested in our this most value. So what we are going to use is an AND operator, and we'll put it 1. So if it is both are equal, then only it is going to give us 1. In case if it is 0, 0 and 1 will become what? 0 itself. Therefore, with the help of this, we are able to identify if a number is odd or even. Yeah. Okay, great. So once we are done with this, let's see what's the next function. So the next function is get ith bit. So what do they mean by this is that, let's say we have a number as 1010, and I want to know what is present in this location, if it is 1 or if it is a 0. First of all, this is for 10. Okay, so we'll be given a number as 10, and we'll be given a number key, or we can say index. So let's say the key now here is, they generally call it 1. So this is 0, 1, 2, 3. So it's like 0 index. Okay, so the key passed here is, let's say, 1. So we have to say that in this key, that is in this, if there is 0 or 1. Cool. Okay. So how to do that? Any idea? Okay. Yes. So let's call this number here. So we have 1010. What we want is a operator, like a number, something here. And based on this, it will give us 1. So the logic is again same. We are going to use AND itself, and here we'll put it 1 itself. Okay. So if it is 1, it is going to return 1. And in case if we are checking for this number, then it will be simply 1010, and here it will be 1, and it will be 10. It is should return us what? 0. Okay, because it's an AND operator. Clear? Okay, but the concept now is how to move our 1 to this position, right? Because our 1, if we know our default 1 will be where? Our default 1 will be at our LSB, least significant bit, right? So for that, we have to take the use of our left shift. Okay, so with the help of, so if you want to shift it here, so what you will do is, first, what is this? This number is nothing but 10, right? So you will be doing 10. No, we'll not do it for 10. Let me just erase this. So what we'll do it is, where is my pen? What we'll do is we'll keep our 10 here. Then what we'll do is we have to shift our 1, right? So this is our 1. Then I'll shift it for, here is what our key will come. Okay, which is this key. This is the key which we are taking here. Okay, this key we are taking here. So if they said it 1, so it will automatically be shifted here. And then afterwards, we'll use our AND operator. Clear? Okay. I hope you have got it. If not, a final explanation, like let's say we have 1010 and we want to find out this. First of all, what is our input? For us, the input will be given as 10, and let's say the key is given as 1. So for that, what we'll do is we know we have what? We have a operator like a 1 as a value, which will be by default here, but we want to shift it to this side. So for that, what we'll do is we'll use our left shift. So we'll say R1, left shift by our key. So this is R1. So it will automatically shift now what? It will shift to 0010. So it will be shifted to this, and this will be called here itself. So 1010. And then we'll use the AND operator for this. And therefore, for this particular we are getting the output as 1. Clear? So let's try to put it in a code format. So let's go it here, and let me write a function for that. Public static method void. What's the name of this? Get add bit. Okay. Do I need any arguments? Yes, I require int a number. Then that's it. No, I want one more. That is int. Let's say key. Okay, good. That what I'll do is I'll simply south. Oh my God, what happened? South and then number. So that is 10 and parenthesis. What it is? 1 left shift of key. Clear? Okay. So for 0, at least there's no issue. We'll get 0 itself. But if there is a 1, there will be a slight issue. Okay, let's see what I mean. So let me first call this function. And why is this error? Okay, here let me pass what? 10. We are checking for 10. And let's say the value is like the index is 1. And if you see, we'll get the answer as 2. Okay. And let's see for 0. For in 0th position, it will be 0 itself. Okay. So this is working fine. But okay, for this position, it worked fine. So 1010, this is 10. So for this position, it worked fine. For this, it gave the output as 2. Let's check for this. This is in which position? 3rd index. So let me put here 3 and let me run. Okay, for hey, wait, 0, 1. Okay, just a silly mistake. What should happen? Actually, R3 is what? R3 is this. This is what? 2. This is what? 1. This is what? R0. These are what I'm speaking. I'm speaking about index or key. So for 3, what it has written? For this, it has returned as 8. Correct. And for this, it will, let's check for 2. For 2, it should return as 0. Okay, cool. So for 2 also, it returns 0. Now, why did it return 8 and 2? Because this is returning the value of it. For example, here, I hope you have already got it. If you have not, this is in which position? This was in 2 raised to 0, which is nothing but 1's position. This was in which position? It was 2 raised to 1, so which is nothing but 2, and that's what it is returning here. This is again in which position? 2 raised to 2, it is 0, but it will become 0 itself at last. And this was in which position? 2 raised to 3. And therefore, it will become 8, and that's what the value is being returned. Okay, but if we are not interested in the values like 8 and 2, and if you are just interested in the values of like you want the output as 0 and 1, then what you can do is you can put this entire thing in a if statement. So if this control C is equal to, like if this is returning to 0, then what you do? South 0. Okay. Else what you do? Else south 1. Okay, so in this way it will work fine, and this I'll put it in parentheses, and now it should completely work fine. So let's check. So let me do it at once for all. Okay, so here I'll start with the 0th index, then I'll start with 1th index, then second, and at last our last index is 3. And if I run it, okay, let me delete this line. This is not required. Okay, and let me run it once again. If you see, we are getting 0, 1, 0, 1. Clear? So we just saw how to get a ith bit. Okay, so it's 11:46. Okay, let's do a few more problems. Set add bit. Okay, now what do you mean by this is, let's say now we have again a number as 1001, and here, so what is this number? This number is 8 plus 1, it will be 9. The number is 9, and let's say the key that they have provided is 0, 1, 2. So once they have provided this, what you have to do is, you have to change this value to 1. Set means you are always setting it to 1. Okay. Clear means in next problem you will be doing clear, and clear means you will be always setting it to 0. That's the concept here. So now they are telling you to set this to 1. Okay. So how can we do this? We can simply put our OR operator. Okay. And we can say like this 0, 0, 0. So this will be 0, 1 will be 1, 0, 0 will be 0, 1, 0 will be 1, and 1, 0 will be 1. And finally, we get our output as 1, 1, 0, 1. Clear? So what's the answer for this? So this will be like 8. 8 plus 4 is 12. 12 plus 1 is 30. Am I right? Let's check if we do for 9. This is what will happen. Let's code it. So let me clear a bit of this here, and let me start coding this. So what I'll do is public static method. Sorry, public static void. What I want, what it is, set ith bit. Set ith bit. Parentheses. What I want is int number, comma. I also want int key. Then after that, so our number. Wait, first I have to do south number or operator. Okay, parentheses. My 1 shifted to my key. Yeah. And let's see if it works. Let me delete this part. I have to do here what? Set ith bit. And let me take the number as, what is the number? 9. And let me change it to, change which one? 0, 1, 2. And let's run it. 30. Clear? Works completely fine. So in case if I change the seconds position, that is zeros, and here if that's the case, then 8 plus 2 will be 10, 10 plus 1 will be 11. So let's do that. So if I change here to 1, this should give me 11. Clear. Cool. So works completely fine. Yes. Okay. So the next one is clear ith bit. So for that, let me take the example again, like 1, 0, 1, 0. So as we discussed previously, clear means it will always be setting back to 0. So let's say the number, this is which number? This is 8 plus 2, it is 10. And our key is what? Key is 1. So that means we have to change it to 0. So it would be 0, 0, 1. Clear? So for this, what I want is, I want here 0, right? I want a 0 here, and I have to use an AND operator. Clear? But how can I get a 0 here? So to get a 0 here, what we can do is, so first we have to shift our 1. So our 1 will be here. So with our left shift, our value will be shifted from let me do it here. So this one will be initially here, and with the left shift, what will happen? Our value will be shifted here. And when our one is here, we will do complement of it. So if we do the complement of one, what will happen is that we'll get the values as 0, 0, sorry, 1, 1, 0, 1. Clear? So if you didn't get it, first one is this. Then if after doing left shift, the one will go here. Okay, let's assume this everything is 0. This is 0, 0, 0. Then after doing the complement, let me draw this symbol. After doing the complement, this will be 1, 1, 0, 1. Okay. And once we get this value, what we'll do is we'll do it, use it here. That is nothing but 1, 0, 1, 0, 1, 1, 0, 1. And if I do AND, so 1, 0 will give us 0, 1, 0 will give us 0, 1, 0 will give us 0, 1, 1 will give us 1. And if you see, the output of this is equal to 8. Yeah. So let's put it to test. Let me come it back and let me say public static method void function name is what? Clear ith bit. Okay. Then do I need arguments? Yes, I need a parameters as int num and int key. Okay, I'll put it here. Then what I have to do? I have written it here. Yes, let me do south directly. First of all, I want a number. Okay. Then for that, which operator I'm using? I'm using AND operator. Okay. Then what I'm doing is first I'm taking 1. I'm shifting it to whatever is the key. And then whatever this after shifting, I'm doing its complement. So let me do the complement like this. Clear? So I hope you have got this. After this, what I'll do is I'll call this function clear ith bit. So our number is what? 10. Our key is what? Key is 1. So the output should be 8. Let's check. Cool. So if you see, we got our output as 8. Then our next function is update ith bit. So this is nothing but if there is a 1, we have to change it to 0. If there is a 0, we have to change it to 1. So this is very easy, because for this, what we'll do is we'll use the logic of this get ith bit. Then after that, okay, let me draw it. So what you'll do? So you will be again provided with the number, and you'll be provided with the key. So from this, we'll get the value. So for that particular key, we'll get to know if it is 0 or 1. If it is 0, we will call which function? We'll call the set function. That is, we'll call this function here. If it is 1, we'll call which function? We'll call the clear function. Okay, we'll clear it to 0. So this will be 1, right? So this is just a copy paste code now. So let me clear this. What's the function name? It is public static. Why this void? What is the function name? Update. Add bit. Right. Do I need? Yes, I need parameters and arguments. So let me take this. Control C, Control V. Okay. Call this get add bit. Get add bit number and key. I have passed it there. Okay. So here I'm doing it south. Instead of south, what I'll do, I'll change this to int. I'm changing the int, and this what I'll do is I'll return 0. Why the number lock is there? Now return 0. And here what I'll return is return 1. Fine. So from that we'll get here 1 or 0 that I'll store the value. So I'll say value, or the ith bit, you can say something like that. This is int value. Then I'll simply put a if condition here. If value equal to 1, then you have to call which function? One means clear function I have to call. Clear add bit. Else which function I have to call? Oh, shit. Okay, else set function I have to call. Set add bit. Okay, this I have to put it in parentheses. And let me check it now. I have to call this function update add bit here. Okay. And yeah. So where is the run? Run. Cool. So we how to compare these values now? This is again pretty simple. Like whatever you have done it here itself, right? It's against doing the same thing. We are just combining that function. So I hope like you can just go through it once. The time is 12. Let's see what all we are left. Okay, so we are left with these three functions. Just try to give it a attempt. If you are able to do it well and good, or just ping it in a comment, and then we'll again look into this. Let me explain what this are. So this problem is you have to clear the last I bit. So let's say if it is 1011, something like this. And if I say clear last I bits, range of I bits. Okay, so then this will do. If I gave you the key as 1, so that means 0 and 1, right? So this entire 2 position should be clear. So this should be like, this should be changed to 1 0 0 0. Okay, if I had a key, for example, let me tell once again, I'm explaining this itself. So I have a number like this, blah, blah, blah. And I gave you the key as 3. So this is 0 1 2 3, right? So up to here, you should get all the values as 0 0, and this should be set as 1 1 1. Clear? So this is which problem? This is the clear last I bits. Then clear range of bits is what? We'll be having a random numbers, let's say 0 1 0 0 1, something like this. Then I'll give you the 2 values here now. I'll give you, let's say J. J would be pointing somewhere here, and I'll give you I. I will be pointing here. So we have to clear the values from here to here. Okay. So this value, so the output of this should be like 1 1 0. This will be 0 0 0 0 0, and this will be 0 1 1. Okay, so this is the range of this. Then count set bits. Okay, now what is set bits? Set bits is nothing but, let's say if you have 1 0 1 1 0 1, here 1 is nothing but is known as set bit. Okay, so here how many set bits are there? 1 2 3 4. 4 set bits are present here. So that's how we have to calculate. Here you have, it's nothing, you have to use a simple loop. So with this help of simple loop, you have to keep on shifting your this entire this, you have to keep on right shifting. So each like one element will be eliminated in each time, and finally you'll get a 0. And before getting a 0, you should have a variable as count. And whenever there is a 1, so again, you can just take the help of this itself. Your function is there. So if you are getting it as 1, then what you have to do is you have to update your count. If it is 0, you have to just skip it. And at last, if you once your loop is ended, that once you get 0, just display this count or return this. Okay. So I hope you have understood this. What is this? Bit manipulation. Okay. So yeah, that's it for today's class. Then we'll catch up in next class. Okay. Sure. Bye.